everybody, welcome to my channel Civil Magister. In this series, I am going to discuss design of steel structures. In the design of steel structures part, the contents I included are introduction part to steel structures, design of connections, design of beams, columns, welded plate girders. At the entry level of analysis and design, we shall design some individual components like columns, individual beams, and then we shall go to the complex structure or integrated structure. At the entry level, it is enough to design individual members. So before that, important things about the steel regarding the composition of steel, types of steel, advantages and disadvantages of steel, what are the properties of steel, and all these things we need to know before going into the design part. So in the first lecture I am including some of these points, so please refer to the lecture. So introduction to steel structures. What are steel structures? A steel structure is a metallic structure framed by joining different structural steel elements to provide rigidity and carry loads. Steel structure is a metallic structure, so this is framed by joining different structural steel elements. So by connecting them, the structural steel elements are connected by either by bolting or by welding. We will frame a steel structure. So what are the structural steel elements? Structural steel elements are individual components of the steel structure. These are made depending upon the type of use. Structural steel is the carbon steel having specific shape and carbon content depending upon the type of use. What is composition of steel? Steel is an alloy of iron and carbon. Apart from carbon, by adding small percentage of manganese, sulfur, phosphorus, chrome, nickel and copper, special properties can be imparted to iron and a variety of steels can be produced. So it is our choice. So it is our choice in selecting the steel in such a way that depending upon the use. So we can modify the steel by adding these elements or by combining two or more elements to form a newer steel which are having improved properties. So what are the types of steel? So types of steel, different structural steel can be produced by slightly changing the chemical composition manufacturing process. So look here, we are having carbon steel, high strength carbon steel, stainless steel. So carbon steel, in this type carbon and manganese are used as extra elements. This imparts high tensile strength but lowers ductility, which is more difficult to weld. So always remember, when you increase carbon content, the ductility of the material gets reduced, but the strength may get increased, but the ductility gets reduced. Increase in carbon content leads to increase in strength, but leads to decrease in ductility. So what is ductility? What is strength? What is yield stress, ultimate stress or tensile stress? All these points I am going to discuss in the next lecture when I discuss about the behavior of the steel under some tensile forces. Okay, so coming to high strength carbon steel. High strength carbon steel, by increasing carbon content, this type of steel can be manufactured, which basically produces steel with comparatively higher strength with less ductility. Stainless steel, nickel and chrome are used along with carbon percentage. This improves corrosion resistance and high temperature resistance of steel. Addition of small quantity of copper also increases the resistance to corrosion. One of the major disadvantages of steel structures is corrosion. So to make the steel resistant to corrosion, so nickel and chrome are used along with carbon to make the steel resistant to corrosion. What are the properties of steel? Properties of steel include physical properties, mechanical properties. Physical properties are the properties which remain constant. Mechanical properties are the properties which changes or else which depends upon the chemical composition and heat treatment. Coming to physical properties, in physical properties, we shall see unit weight of steel, that is density of steel, which is 7850 kg per cubic meter. Modulus of elasticity or Young's modulus is 2 times 10 power 5 Newton per mm square. Poisson's ratio mu equals to 0.3. Modulus of rigidity G equals to 0.769 multiplied by 10 power 5 Newton per mm square. Coefficient of thermal expansion alpha is equals to 12 times 10 power 6 per degree centigrade. Mechanical properties includes yield stress, tensile stress or ultimate stress, ductility, toughness, weldability. These points, yield stress, tensile stress or yield stress, ductility, toughness, weldability, I am going to discuss in the later classes while discussing about the behavior of the steel under loads. Okay. Then coming to what are the advantages and disadvantages of the steel structures. There are many advantages but some disadvantages for selecting steel as a construction material. So what are the advantages? So high strength per unit mass, that is high strength per unit mass, which means with a lesser cross sectional area you can gain more strength from the steel. Unlike in concrete where you need to increase its cross sectional area to increase its load carrying capacity, but in this case you require less cross sectional area to carry more amount of load. Assured quality and high durability. So this steel structure is made out of structural steel elements. Structural steel elements are already prefabricated in the shop itself under controlled temperature and controlled environment. Unlike in concrete, the where the concrete is casted in the field, some variations may occur uh, while casting the concrete, like temperature variation, water cement ratio. While steel is manufactured under controlled temperature and controlled atmosphere in the shop, so we can have assurance about the quality and durability. Easy and fast erection. So steel components are already manufactured in the shop itself. We just need to bring them and erect them in the field where we require, either by using bolted connections or by using welded connections. So it is very fast and easy erection, as already casted members we need to bring from the shop. Structures can be strengthened in future. Sometimes it may arise a situation where you need to increase the strength of the existing structure. An old structure you need to strengthen. Then in such a situation you can increase its strength by adding some plates, by welding some plates to the existing structure, by bolting some plates to the existing structure so that it can be stiffened. Old structure can be stiffened, so which is not possible in case of concrete structures. So this is one of the advantages in steel structures. Easy dismantling and transportation in case of bolted connections. So bolted connections are the type of connections where you can remove them easily by unscrewing them, and these elements can be transported to other locations and again you can erect there with the bolted connections. So this might be difficult in case of welded connections, but bolted connections are the type of connections where you are having this type of flexibility. Material is reusable. Steel material is reused again for the other purposes by melting them and molding them into other form of shape. Okay, so this is one of the advantage. So one of the advantages that make architectures or structural engineers to use steel as a component is so in such a case where industrial buildings need more space, avoiding columns in the rooms in such a case where they require long spans. So long span structures can be obtained by using these steel structures. Okay, this is the one of the advantage used by structural engineers. Disadvantages: there is a chance of corrosion. So steel structures are prone to corrosion. So if it is prone to corrosion means we need to maintain that one to resist corrosion. So we need to paint the structure. Okay, so that is high maintenance cost. Steel members become costly in case of improper design. When the design becomes inefficient or insignificant, then the structure becomes uneconomical. Where the members increases, the cost of the structure also increases. So these are the advantages and some of the disadvantages that were seen regarding the steel structures. So a structural engineer is one who analyzes and designs the structure. Analysis part includes to finding out the unknown forces and unknown moments. By using these unknown forces and unknown moments, he designs the structure. Design part includes calculation of the dimensions. So dimensions includes thickness and width of the members, depth of the members, where structural engineer is restricted to use some particular dimensions only. These particular dimensions he needs to use because the market, he needs to use the materials in such a way that those are available in the market. So a company may not cast for an individual member the steel structures. They cannot, the rolled steel sections they cannot cast for a particular individual member. It becomes uneconomical for the manufacturer. So it is the thing structural engineer to do, that is he should design the structure in such a way that those are available in the market. These are most commonly available rolled steel sections in the market. Depending upon depending upon their shape, rolled steel sections are classified as I section, channel section, angle section, T section, bars, tubes, plates, and flats. These are the classifications based upon the shape, and again based upon the unit weight. I section is classified as Indian Standard Junior Beam, Indian Standard Light Beam, Indian Standard Medium Beam, Indian Standard Wide Flange Beam, Indian Standard Heavy Beam, Indian Standard Junior Beam ISJB, Indian Standard Light Beam ISLB, Indian Standard Medium Beam ISMB, Indian Standard Wide Flange Beam ISWB, Indian Standard Heavy Beam ISHB. These are the designations for the beams. ISJB means Indian Standard Junior Beam. So while designating, we will designate the beam as I ISM, for example, ISMB 500 at 0.4852 kilonewton per meter, which means that 500 ISMB is the beam that belongs to the class, that is ISMB belongs to which class? Medium beam. 500 refers to overall depth of the beam. 0.85 refers to unit weight of the beam per meter length. 0.852 kilonewton per meter. Similarly, channel sections are classified as Indian Standard Junior Channel ISJC, Indian Standard Light Channel ISLC, Indian Standard Medium Channel ISMC, Indian Standard Special Channel ISSC. These are designated as ISMC 300 at 0.351 kilonewton per meter. As usual, ISMC refers to Indian Standard Medium Channel, 300 refers to overall depth, 0.351 kilonewton per meter refers to unit weight of the channel per meter length. And similarly, angle sections, rolled steel angle sections, Indian Standard Equal Angle and Indian Standard Unequal Angle section consists of two legs. So we are designating that one as ISA 150 by 150 by 12 mm. So that is 150 and 150 are lengths of the two legs. 12 mm is thickness of the two legs. So here I am showing you an example. 150 by 150 by 150 by 12 is an equal angle. So equal angle section. If I say that ISA 110 by 150 by 10, it is an unequal angle. Rolled steel T sections. Rolled steel T sections consists of rolled steel Indian standard normal T bars ISNT, Indian standard heavy flanged T bars ISHT, Indian standard special leg T bars ISLT, Indian standard light T bars ISLT, Indian standard junior T bars ISJT. For example, it is designated as ISNT 60 at 53 Newton per meter. Rolled steel bars are solid bars. These are classified as Indian standard round bars ISRO. For example, these are designated as ISRO 16. So here ISRO refers to Indian standard round bar, 16 here refers to diameter of the round bar. Similarly, Indian standard square bars ISSQ designated as ISSQ 20. For example, 20 is the side for half square. Rolled steel tubes, these are hollow sections. These are classified as uh, depending upon their thickness, these are classified as light class, medium class, heavy class. Rolled steel flats, these are classified as Indian standard flats. These Indian standard flats are designated as 80 ISF 10. For example, 80 here refers to width, ISF refers to Indian standard flat, 10 here refers to thickness. Rolled steel plates. Rolled steel plates are represented as ISPL, Indian standard plates. For example, these are designated as ISPL 2000 by 1000 by 6. Here 2000 refers to length, 1000 refers to width, and 6 refers to thickness. This one is built up section. So sometimes available rolled steel sections may not be sufficient. They may not be sufficient to carry the loads coming onto the structure. They may become insignificant in such a situation. In such condition, we need to develop another section by combining the available rolled steel sections. The situation where the available rolled steel sections may not be capable of resisting the applied loads, then in such a situation we need to develop another new section by joining two or more available rolled steel sections. Such a section is called built up section. So here you can see built up section. This is called a plate girder, welded plate girder made by joining flange plates and web plate, and here they have used some stiffeners in the form of plates. Where do we use these steel structures? So I am showing you some steel structures. Just please see those steel structures and observe some rolled steel sections and built up sections in those steel structures. An industrial roof truss, it can be used in industrial roof truss where long spans are required. So in such a situation, if we go for concrete type of structure, then concrete, as the span of the beam increases, then we need to increase depth of the beam, which becomes uneconomical. So in such a situation, we can use a steel where we can obtain more strength from the lesser area. Okay, so this is industrial roof truss. And in an industrial structure, airport terminal, electrical transmission towers. Most of the electrical transmission towers may be cell towers, maybe TV towers. All these towers are made out of angular sections. Steel bridges most often. So steel bridges by using trusses, different types of trusses, Pratt truss, Warren truss, Howe truss. So different types of trusses, they make use of steel. Another steel bridge. This is also a bridge made by using plate girder. Plate girder is one of the built up section. Steel structure, another steel structure. So this, you can see most of the steel structure is made out of 5 sections. Auditoriums, another auditorium you can see. So here they made use of solid round bars. They have provided some lacings. So we shall discuss what are the lacings, battens, all these things in the coming classes. Gantry girder in industry to lift the loads. To lift heavy loads we make use of gantry girder, which is made out of steel itself. So cranes boom, you can see. So this one is cranes boom. It's a compression member. So this is also made out of steel. And another crane, so boom, is made out of steel. Overhead water tanks. Overhead water tanks, if you make use of steel correctly, it can be used as water tank, leak resistant water tank. Parking shelters, bus shelters. So one of the famous structure made out of steel, Eiffel Tower, is also made out of steel by using some sections. Steel is that type of material which looks aesthetically good, having less dead weight, and used where long spans are required. Architects make use of this advantage in steel to be used as construction material. So with this I will end up this class. In the later classes we shall be seeing some structure behavior of the steel, and of course limit state design method of designing the steel structures by using limit state method. Okay, thank you.